Okay, so who wants to try to show how Grant Sanderson
I will.
found the area of a circle?
Okay, so he cut the circle into these rings here.
Okay.
And then what he did is he looked at how like to find like the thickness of these rings here.
Uh-huh.
They were like dx, I think.
Okay, so they had some thickness, and he called that dx.
So, and then what he did is he took all of these and he cut them here, like
Sort of opening them up.
he like if you had a ring, he would like kind of open it
Okay.
so that it would look sort of like a rectangle. It looked like this.
All right. Why is it not a perfect rectangle?
Oh, when you stretch it out, like if you lay it flat, it gets sort of bent along here, and you need them to like roll to connect.
Yeah. So why does it get bent though? Why are these edges bent?
Well,
You need
because this interior, like for this big one,
Yeah.
this interior circle is smaller than the exterior circle.
Do you see that?
Yeah.
Yeah. So that's why. So the one on the top here, when you unroll it, is just a little bit shorter than the one on the bottom. So that's why they're bent a little bit.
So-
That's good. I'm glad you noticed that actually.
Then what he did is he put them all straight up and down.
So he sort of said that they were
Rectangles.
rectangles.
Rectangles. And
Okay. So he pretended they were rectangles. That's fine.
he putting them all straight up and down like this,
Uh huh.
and it continued on.
Mhm.
And then he said he took the line here, he took across here, and he went up wherever they ended.
Okay.
And this is the area of a triangle, and so this amount here, this bottom side was the radius,
Okay. Why?
because this, when you cut through here, this line here is from the center to the outside. That's
Okay.
the radius,
All right.
R. And then up top was the circumference.
Okay. Which is what?
It's the I don't.
The circumference is 2 pi r.
So the circumference is.
It's pi times the diameter.
Yeah.
It's 2 pi r.
Yeah. So how high is that this rectangle? How tall is it?
2 pi r.
2 pi r.
Okay. 2 pi r. And then it's 1/2. The area of a triangle is 1/2 base times height.
Okay.
So he did that here. So he had 2 pi r, so he got pi r.
Uh huh.
So then he got, and then he had to multiply, so he got pi r times r, which is pi r squared.
Very good. Was there anything you'd like to add here?
No.
No. Okay.
He said this was an approximation, and if you cut the circle into like smaller and smaller rings,
Uh huh.
the approximation would get better and better,
Okay.
because this would more like fit the lines of the triangle.
All right. So let me ask maybe a challenge question. So this one's for you, since your brother did a lot of the talking here. So the thickness here, which he called dx, or just whatever the thickness is, as we cut it smaller and smaller, what happens to that thickness?
Well, that thickness gets smaller and smaller, and sort of as a result of that getting smaller, your circle cuts that you're making
Uh-huh.
tend to look more like rectangles because the inner and outer circles differ less and less.
Okay, very good. But one other interesting thing that happens is that this side of the triangle, when you unfold them and make the triangle, this side of the triangle never changes in length,
No.
no matter how small those cuts are. So why is that?
Well, because you're cutting you have more cuts, but they're thinner. Like if you cut each of these in half, you've got twice as many cuts, but they're half as thick.
Uh-huh.
As a result, they'll still be the same length.
Okay.
The radius of the circle never changes.
Yeah, that's right. The radius of the circle never changes. Okay, so one last, very good work, guys. I'm actually really pleased with how well you were able to explain what he was talking about in the movie. So, one last thing, I made some 3D prints that may or may not help us understand this a little better. So, I want to explore those now.